This second lesson in perception is going to look at visual cues and constancies. So a visual cue is anything in the environment that gives us information. That could be things to do with movement, distance, or where things are in relation to each other. Anything that provides us with that sort of information is regarded as a visual cue. Now, depth is something we're going to talk a lot about in this particular topic, and depth allows us to understand that there are objects in the distance, there's objects in the foreground, so close to us, and there's objects in between. And that helps us understand how far something is away from us. And we're going to use this image here, very famous image from the Beatles' Abbey Road album, to help us understand depth and give you a few examples. So on your specification, it talks about two types of depth cues in particular, monocular and binocular. Monocular depth cues are how we can judge depth and distance using one eye. Binocular depth cues allow us to judge depth and distance, but we need both eyes in order to do this. So monocular, we can use one eye. Binocular, we can use two eyes. And we're going to give you a few examples now to show you the differences between monocular and binocular depth cues. So for monocular depth cues, we have relative size. So objects of a similar size, so we've got the cars here on the left-hand side, they appear smaller when they're further away. We know that car is further away because it's smaller than the car that is nearest to us. We've also got height in plane. So objects which appear higher in a visual field will appear further away. So we've got the cars here in the distance. They are much higher in this image than the man here in the white suit. So we know that the cars in the distance are further away because they are much higher in that visual field. We've also got two other monocular depth cues. If we look at the shape of the road here, we can use something called linear perspective. Now this is where parallel lines start to converge or come together in the distance. And the further away an object is, the more the lines come together. So where you've got the four men here at the front, the lines are far apart, so they're very close. But as the lines get further and further and get closer and closer together in the distance, we know that that's much further away because those parallel lines are starting to converge in the distance. Now we've also got something called occlusion. Now this is where objects that are behind or obscured by something are further away. So if something's being obscured or hidden, then we know it's further away. So the cars behind that taxi there, they're all being obscured by the taxi, so we know they are further away than the taxi. Now we also have binocular depth cues. Now remember, this requires both of our eyes. The first one we're going to look at is convergence. So convergence is when our eyes follow an object, they start to come together. The word convergence or converge just means to come together. Now the muscles around our eyes contract when our eyes meet or come together, and they relax when we look straight ahead. And what happens is this muscle information, how much our eyes are having to work, gets sent to our brain. And this gives us information about how far something is away. So another way to think of it is the eyes turns inwards the more close something is. So if you put a pen really close to your eyes will start to converge. They'll start to join in the middle. And that will send that information that our eyes are going to work really hard here to join together in the middle. It will send that information to your brain, and then your brain will work out how far away that object is. If you put that pen far in the distance, your eyes don't have to come together or meet in the middle. So your eyes are nice and relaxed, and that information will get sent to your brain, and then you will know that that object is further away. The last thing we're going to look at is retinal disparity. Now, retinal disparity is this idea that our eyes are only a few centimeters apart. So each of our eyes sees the world slightly differently. Now, the images from each eye are always going to be slightly different. And what the brain does is it blends or merges these images together to create a single image. But this merging process helps the brain work out how far objects are away. And the more similar the objects are, when you do something like this image here, the more similar the objects are, the further away that object is. The closer the image is, the more that image will jump between your thumbs. So that merging process helps your brain to work out how far objects are away from you.